Hey, what's up guys? Tim Weaver here with Studio 4 Media with another tutorial. Today, inside of Maya, we're going to be making this Lego block creator custom plugin using Python. And let me show you how it works real quick. So we have the block width that we can change and the block depth that we can change. And whenever we change this and we hit create block, it's going to create a Lego piece for us that is the same size as we entered. So now we have a 4x2 Lego piece here. If I want to make maybe like a 1x6, it'll generate that for us, and we have a complete Lego piece that we can then use to start building a little Lego set. So it's a pretty cool plugin. It's very simple, and it's easy to make using Python inside the script editor. Now, don't worry if you don't have any programming knowledge, because I'm going to be taking this one step at a time, trying to go as easy as possible so anybody can follow along. Obviously, if you have a little bit of programming skills or you know Python, at least a little bit, it might be easier to follow. But I'm going to try to make it to where anybody that is watching this can follow along. So let's go ahead and get started. I'm going to exit out of this and then go up here to File, New Scene, and Don't Save. So for those of you that don't know, Maya has built within it a script editor that you can code in either Mel or Python. Mel is the Maya embedded language, and that is what Maya is built using. You can find that down here in the lower right-hand side. There's a script editor button. If I click that, it pulls up the script editor. Now, if you can't see that on my screen, or if it's not there for you, you can go up here to Windows, go to General Editors. It's right here as well, Script Editor. And you'll see we'll have a couple tabs here. The first one is Mel, that's that Maya embedded language, and then we have Python. Now, if you can't see either of these two tabs, you can hit the plus button here, and you can pull up either the Mel or Python tab. So let me show you exactly how this works. So if I go up here and if I create a new polygon cube, I'm just going to click it once to have the default settings. You can see it creates a cube, and then it actually outputs some code inside of our script editor output. So if I copy this line of code here and delete this cube, I'm inside the Mel script editor right now. I'm going to copy and then paste that line of code that I copied up here. And if I execute this by pressing the execute button, you can see it's going to create that same cube that we just had. So you can actually create objects using code inside of Maya. I can do it again here. I'll copy this polycube, paste it, and I can change some of the parameters here too. I have the width, the height. I can make the height maybe 2, just to show what this does. And now you see I have a cube here that's been created using nothing but this line of code. So that's what the Maya embedded language does. You'll notice that if I deselect it or select it, it'll actually spit out some code too, and you can use that inside of this script editor here to actually select and deselect objects. You can do pretty much anything that you normally would do using the code. And that comes in handy whenever you're trying to make your own custom plugins and make things a little bit easier that would be more difficult to do by hand. So that's what the Maya embedded language is, but you can also do this inside of Python as well. In order to do it in Python, you need to import all of the Maya commands, and you can do that pretty easily by just saying import maya.cmds, that's Maya commands, and we're going to assign all of the commands to a variable. So I'm going to say as cmds. So what this does is we're saying, okay, I want all the Maya commands to be assigned to this one variable. It can be named whatever you want, but I just named it cmds. And now, if we want to make that same polycube, all we have to do is say cmds dot polycube, and then specify the height. I'll say it's just 1, the width 1, depth equal to 1. Then I could say, okay, sx, that's the subdivisions in the x-axis, set to 1. Subdivisions in the z-axis, set to 1. Now if I execute this code, it's going to create that same block that we had up here, because we're using that same, you see, polycube is the Maya command that was used up here, polycube. And then we specify the width, the height, the depth, everything else. So let me go ahead and run this, and then you'll see it's going to spit out that polygon cube. Now you'll notice that all of our code over here is gone. We just executed that and our code got erased. Well, you can hit Control-Z and it'll bring the code back, but even better, what you can do is you can highlight all of your code and hit Control-Enter instead of hitting this execute button. And once you've highlighted it and hit Control-Enter, it'll execute that code, but it won't erase it. And that way you don't have to keep going back and hitting Control Z. So we're going to be using that a lot, just highlighting one piece of code or the entirety of the code and then hit Control Enter in order to execute whichever piece we want. So this is how you create a cube inside of Maya using a Python script. And you can do this with any object, really. I can go in here and I can say, okay, I want to do commands.poly cylinder. And for a cylinder, you specify the radius. I'll make mine 0.25 and the height 0.2. And now if I just highlight this one command and hit Control Enter, it'll execute only the thing I have highlighted. So I'm going to highlight this, Control Enter, and you see now it's made it look a little cylinder, like a little squished cylinder. I can move that up here. And so yeah, you can create any of these objects really. And what we want to do, since we're making a Lego piece, is create a cube that's kind of in the shape of a Lego block, and then a cylinder that can be used as the little nubs that are on top. Okay, so here's our polycube. We've already assigned the height, the width, and the depth, but let's edit those real quick to make it match a little bit more of what a cube looks like. So height, we'll leave it 1. Width, let's make it 3. Depth, I'm going to say 1.5. The subdivisions in the x-axis, I'm going to say that should be set to 4. And then subdivisions in z, I'll set that to 2. So now if I execute everything, here's what we get. I have a cube here, and you see it's kind of elongated in the proper shape of a Lego block. And now it's subdivided into 8 different pieces, 4 on each side of the x-axis. Now inside of here, if I hit 4, is our cylinder. You can see that the cylinder is, everything's created at the origin, right? So the block is actually situated at the origin, the cylinder is as well, and I can move it up here. And if I hit 5 now, you can see there's our cylinder. So our end goal here, what we want at the end is to have this cylinder be in the proper position of where this subdivision is on all these locations, right? Because we want it to be like, this is a 4x2 block. We'd want this to be, if I duplicate it over here, we'd want all these to be in the proper position, right? So it emulates that Lego block. That's what we're looking for. Right now, what we get when we execute our code is just a cylinder and then this block that has the proper subdivisions, but it's not situated in the right position. The cylinder is not situated properly. So what we can do to situate this cylinder is use the Maya move command. So if I go in here and I say commands.move, I can actually move this up because it starts at the origin. I'm going to move it up, let's say 0.6. And I want to move that in the y direction. So I'll say y, move y equals true. I'm going to say A is equal to true as well. Now A just stands for absolute. It's an absolute operation, right? Inside of Maya, you have like an absolute transform and a relative transform. I'm just specifying here that we want this to be an absolute transform. If you don't understand that, don't worry about it. Just make sure you include it. So it keeps everything nice and neat. So now if I run this, what we'll get is the cylinder has now been moved from the origin up to the top here. And that's great. So that's one axis that we have done. We've moved it up in the proper location in the y-axis. Now we just need to do the same thing in the z-axis and the x-axis. We want it to be moved to where it aligns perfectly with this subdivided area. Okay, so we can use the exact same command. We can say I want to move it. This time I want to move it, commands.move in the x-axis. Now I've already gone through here and gotten the correct values to make it be in the right position. So I'm going to enter these values. You can just copy my values if you want to follow along. And it's going to look a little bit weird, and it'll make sense here a little bit later. So I'm going to say negative 1.58. Then I'm going to say plus, make sure you add a parenthesis, 1 plus 0.55, end parenthesis, multiplied by 0.77. Now again, this looks a little weird, but I've laid it out like this for a specific reason, and it's going to make sense more here in just a little bit. So this is going to be our movement in the x-axis, equal to true, and make sure it's a capital T, and then set absolute equal to true as well. So that's our movement in the x-axis. I'm going to be doing a similar movement in the z-axis, so I'm just going to copy this, paste it here at the bottom, call this move z. Instead, I'm going to be going negative 0.84, and the rest of this is probably fine. I'll just say negative 0.8 here. We're multiplying by negative, or just regular 0.8. Okay, so if I execute this code, let's see what we get. So we have our cube created, our block created with the subdivisions. We have our cylinder here aligned the way we want it, with it being positioned in the proper subdivided area. But we only have one of them, right? We want this to be in every single subdivided area. So that's a problem. Another problem we have is that you can tell these are two separate objects, right? So whenever this was moved over here, like I can move each one individually. And we don't want that either. We want this to be one solid Lego block. So we can use an operation that combines both of these together into one solid object. Before we do that, though, we have to make sure that we assign each one of these to a variable. Okay, let me show you what I mean when I say that. So right now, we just have a line of code that just makes the block, okay? And we have another line of code that just makes the cylinder. But we want to assign these to a variable. So I'm going to say block equals this cube that we've been creating. And I'm going to say nub, I'll just call this the nub for the one on top, equals to the cylinder. So what this does is it won't actually create anything until we tell it to, right? And then what you can do is you can use this information, then this block, and I can manipulate it in a certain way, right? So in fact, if I run this command, it's going to produce, actually I'll run everything. It's going to produce the exact same thing as what we had before, right? Except now we have these tied to a variable, and we can use those variables to manipulate them in certain ways. And that's exactly what we want to do next. We want to, remember, combine both of these into one object. And now that we have these assigned as variables, we can say, okay, I'm going to use this command dot poly c, capital C, bool operation, B-O-O-L operation. And I'm going to combine the block and the nub together into one object. The operation, OP, is going to be set to number 1. And that operation means there's different options here. Number 1 means union, which is what we're doing here. We're combining two separate objects, the two separate objects being the block and the nub, and we're going to be using that as the union option. And then we're going to say ch is equal to false. Ch stands for caching. You have to assign that, but we don't want it to cache this object. We want to just say that that's equal to false. So now what we're doing here, let's go and run through everything again. We're creating a block. We're setting that block to a variable. We're creating our cylinder, setting that cylinder to a variable. We're going to move up our cylinder to the proper location, and then we're going to combine the block and the nub object into one object, right? And at the very end of it, we want that one object to be our block. So we can say, okay, this combined object is equal to our original block object. And now if we run this whole thing, Control Enter, you see we have our cylinder moved to the proper location, our block being created, and now it's been combined into one object. So this is looking really good. We are definitely well on our way. But again, one of the other problems that we had was that we're only creating one nub right now. We want to have one nub for each one of our subdivided areas. And so I could go through and I could create, just copy this several times, 8 times, however many different areas we need it in. But the problem is that that's not very, efficient. And then also that only works for this one particular block. We want to create several different Lego pieces of different sizes. We want it to be responsive based on the user input. And so in order to do that, we need to set up in a little bit different way. We can't just hard code it in. We can't just force it to be at this specific location and then assign it individually for each individual nub, because that's only going to be useful for this one particular block, right? So the way you can do this is you can use something called a for loop. And if you've never coded before, I'll explain what a for loop is. Basically, I'm going to say for some variable, I'm going to name I, in a range of 4. What this means is that I'm going to move my poly creation inside this for loop. So I'm creating a poly cylinder the entirety of this loop. And this loop just goes from 1 to 4. So I'm going to be creating 4 cylinders, right? And if I delete this and I run this line of code only, you can see, well, they're all on top of each other, so you can't see it. But if I move them out of the way, we'll have 4 different cylinders here that have been created, right? And that's because we're counting this I variable from 1 to 4, and we're creating 4 different objects because that's what's inside of our loop here. Once it gets to 4, it kicks us out of the loop, and then it runs the rest of the code. So that's how a for loop works. It just counts to some number, and then while it's counting, it executes all the code that's inside of there. And this is pretty useful. For example, if I move this move command inside the for loop, now you see, okay, so it's going to be moving this 0.6 in the y-axis, so it's going to be moving it up, which is good. That's what we want. But you'll notice that if I run this, they're all going to still be in the same location. So it's moved it up off the origin, but they're all still, on top of each other. And we don't want that. We want them to be kind of separated out in a specific position. So I'm gonna copy this move command just to show you how this works. Move this in the x-axis. Now instead of assigning a number to this, I'm going to assign my variable I up here. Okay, so I'm going to say I as our move number. And the way this works, remember I just counts up. So it goes 1, then it goes 2, 3, 4. So that's the same as entering, okay, 1, then 2, then 3, then 4. It just iterates up. So what this is going to do is it's going to create the first cylinder at position 1. The next time it goes through the loop, it's going to create the second cylinder, but this time at position 2. And so on and so forth. And so if I run this by setting this to I, I'm just running this line, this for loop here, it's going to create 4 cylinders, but it's going to be spaced out evenly throughout the x-axis. So I'll hit Control-Enter, and now I have 4 cylinders that are spaced out 1 unit apart from each other. So that's pretty cool. We can create these nubs here just by using a for loop, and then if we change this range, say I wanted this to be like 8, I can delete these, and now it'll create 8 cylinders and space them out. So you can probably see where this is going. As we change this number, it changes whatever the amount of nubs that we have on top, right? And so this works great, and it looks good, but it's not spaced correctly. Like if I create my block, it's not exactly spaced out properly. And you'll notice that it's only creating really one side. We want it to be 2 sides, right? We want it to be on this side here. If I duplicate, we want it to be on this side over here as well. So how can we do that? Well, we can use another for loop, right? So I can say, okay, I'm going to say for a different variable, this time j, in range. This time I'm going to say 2. So this is called a nested for loop, right? So we have our first for loop that goes through 4 times. Our second for loop is going to count only twice. And if I create this block, you'll notice that this is actually the exact same numbers as our subdivisions, right? So we're subdivided 4 times in the x-axis here, and we're subdivided twice in the z-axis here. So we want to create 4, 1, 2, 3, 4. Then we want to move over in the z-axis and then create 4 more in the x-axis, 1, 2, 3, 4. So if I do that real quick, I'll show you how this works. Let me delete this block. I'm just going to copy this line here, paste it, and instead of saying at the I-axis, I'm going to say, or the I variable, I'm going to say the j variable, and I'm going to be moving this in the z-axis. So now we're going to be moving up in the y. We're going to create 4 little cylinders on the x-axis, each time being spaced out by 1 as we iterate up. And then we're going to create our cylinders, make sure they're being moved over to the right in the z-axis using this j command here. So if I go ahead and execute this, here you can see we have our nubs now being created, 4 of them. Then it shifts over to the left in our z-axis and then creates 4 more. So this is exactly what we want. of course, our block is not exactly the right size, so we can work on the sizes here. And in fact, I'm going to delete this here, and now it's going to make a little bit more sense as to why I used this weird looking equation down here. I'm going to take these, I'm going to just add them to our for loop. Remember, this is the movement for our X and Z. And I'm going to, instead of having this 1 here, I'm going to replace that with I. And the second one is our Z axis. I'm going to replace it with J. So now if I highlight everything, I create it, everything is spaced out properly, and we have the very beginnings of a Lego block. So this is looking really cool. And in fact, I can even put in this this combination here where we combine our two elements, and that way if I run all of it, we have everything combined into one solid Lego block. So this is looking really good. We're definitely on our way. We have everything lined up in a way that it can be very responsive. The way we're coding makes it really easy to change. It can be responsive as we continue along. But as I'm looking here, I'm noticing that if I rotate underneath the bottom of the block, it looks pretty, doesn't look good, right? Like it's just a solid piece of block. Doesn't look like a Lego on the bottom here. Top looks great. We got our nubs in the right position. It's all combined into one piece, but the bottom doesn't look too good. So let's go ahead and address that now. What I'm going to do is I'm going to create another cylinder, or another block here, a cube, and this is just going to be a temporary cube. So I'm going to say temporary cube is equal to, I'm looking up here at the size of my other cube, okay? So I'm going to say commands.polycube, I'm making another cube, and my height, I want it to be just a little bit less than the height of my current cube, so that's 0.8. My width, again, a little bit less, 2.8. My depth, 1.3. My subdivisions in the x-axis can just be 1, and in the z-axis can just be 1 as well. So what happens if I make this block? Well, we'll hit Control-Enter, and you'll see that this is a, let me delete this and remake it so it's in the proper position. What we've done here is if I hit 4 for wireframe, we've created this block inside of our other block. Just slightly smaller, right? But we obviously need to move it down in the y-axis a little bit. And then if we have it positioned properly, what we can do is we can say, okay, any place that these two blocks are intersecting, I want to remove everything inside of there. And what that will do is it create this hollow piece inside of our block and give us that hollow-looking Lego block look. So, like I said, the first thing we need to do is move it down in the y-axis. No big deal. Commands.move. We want it to be moved down, not much really. Let's try 0.1 in the y-axis. Let's try that and make sure that it's lined up correctly. I'll highlight everything, Control-Enter, and there we go. So now we've moved it down in the y-axis. And now I'm going to be doing that same command as I did up here where I use the operation 1 to combine them, except this time I'm going to be using a different operation to take the difference. So I'm going to say block equal the same command, commands.poly cbool operation, OP, and the two blocks that I want to be interacting with is the block and the temporary block that we have assigned up here, right? That's our temporary block, so I'm going to be using that. And this time I'm going to be using operation 2. And operation 2 is using the difference between the two blocks. So I'm going to be saying, okay, whatever the difference is between these two blocks, go ahead and remove that, right? And then the caching, again, I'll set to false. So now, if we run this whole thing, what we get, if I hit 5, we get our Lego piece. Our block was created inside of it. It took the difference, and now it's all being assigned back to our original block, and we get this nice looking Lego piece. So everything is, this is looking really good, you know? I mean, you could even stop here if you wanted to and just say, okay, this is as far as I want to go. It looks pretty good. I'm going to take it a little bit further and create the inner nubs inside of here where the Lego pieces actually connect together. And to do this, I'm just going to be creating just a cylinder, right? Polygon cylinder. It's not too difficult. I'm going to say commands dot polycylinder. And I'm going to make the radius equal to 0. Again, I've played around with these numbers, so I kind of have them laid out in a position that looks good. So 0.3255. The height is equal to 0.7. And the subdivisions in the x-axis, I'm going to make that equal to 10. And you'll see what that looks like here as I create this. So I'm going to say, okay, let me highlight this, Control-Enter, create it. Now I have this cylinder, but since we set the subdivisions to 10, you can see it's kind of jaggedy along the edge here. It's not really smooth. And that's kind of how the Lego piece looks at the bottom, right? That's how they snap together, because you have this more subdivided area down here that's more jaggedy. That's how the Lego pieces connect together. But you'll notice that it's not hollow on the inside. We want that to be kind of hollow. And so to achieve that, we can do the same thing we did up here. We'll make this temporary cylinder that's slightly smaller than this cylinder, then use this command to remove it, and then we have our hollowed out cylinder. In order to do that, we have to assign this cylinder to a variable, right? So kind of like just like we did up here with our block, we're just assigning that to a new variable. I'll call this my inner nubs equals to the cylinder. Now I can say, okay, I want my center cylinder to be just slightly smaller, poly cylinder, slightly smaller than the one I just created. So my radius, poly cylinder. My radius can be equal to 0.25, and my height can be equal to 1, a little bit larger, so we make sure we get everything. Subdivisions can be the same. So now we're just creating another cylinder that's, I can just run this, Control-Enter, inside of here, and then it's slightly larger, so we can take the difference now, and then it'll remove everything inside of there, and it should be hollow. So if I do that, I can say, okay, my inner nub is equal to commands.poly c bool operations. The same thing as we did earlier, right? I'm going to be taking the difference between the inner nub and the center, and I'm going to be using operation 2, ch equal to false. So let me delete these two, run this whole thing, and we get an error. Inner nubs with an S is what I named it for some reason. Run that again, and there we go. So we have our nub here. Now it's hollow on the inside, and it's not positioned quite right. Well, I think it's not positioned right because I moved that block before. Let me run everything. Highlight everything, Control-Enter. Here's what we get. All right, so this is looking good. We have our one nub here in our proper location. What I really want is nubs on either side like this, and that gives us the final look. And that would be our final 4x2 Lego piece, right? So I can do that easily. This time it'll be the same thing as we did with our nubs for on top, right? We're just going to be putting them in a loop. We want to create the cylinder, move it to a specific location, and then create another one, move it, create another one. So it's going to be pretty much the same thing we did up here in our for loop. We're just iterating through a certain amount of times, and then creating this cylinder however many times we need. So I can say the same thing for I in range. I'll say 3 this time, 1 less than our first range. We want it to, again, be utilized for both the X and the Z axis. So this will be a nested for loop for I in range. Now all this can go inside of here. And we also want it to be moved as well, right? So I can basically, I'm just going to go up here and copy all these move commands because it's going to be very similar to what we had before. And in fact, I'm going to copy all this. So even the very last command that combines everything together, because that's what we want to do is once we're done, make sure that those cylinders are combined into the original Lego piece. So let me copy all of this, paste it inside of our for loop, and mess around with the values a little bit. Let's say, okay, the first movement in my y-axis, I want it to be negative 0.05. Second movement looks pretty good. Let me change this from 0.55 to 1, and let's change this to 0.8. Again, change this from 0.55 to 1, and that looks good. We want our final block to combine the block and the inner nubs all together in one solid piece. And let's run this and see what we get. I'm going to highlight everything, Control Enter, and we get an error. Cannot perform Boolean operation. Let's make sure that we've labeled everything correctly. Cbool block. Inner nubs, that's right. Going through here looking for any type of incorrect statement here. What did the error say? Cannot perform Boolean operation. That would be down here, operation 1. Oh, okay, I see. So it's trying to, we have our range set to 2, right? So it's trying to create in an area that's not permitted. So we want to set this down to 1. So 1 less than what our subdivisions in the z-axis is, and set that to 1. 1 less than our subdivisions in the x-axis, so that set that to 3. Let's try that maybe. That works. Yeah, here we go. So there we have it. We have our Lego piece created. This is a block that is a 4x2. Pretty cool. Again, if this is as far as you want to go, you can now know how to use some Python code to create a Lego block. I'm going to, again, take it a little bit further to try to make a fully user interactive plugin that we can use. And let me go in here and let me start labeling everything, because our code's getting a little bit long and it might be confusing as to what everything does. So let's go back and kind of do a recap, and as we recapping, label everything. So the first thing we do is we create our main block. All right, that's our base. Then we create the nubs on the top. And we use that by going through our for loop. And then we create our, actually we remove the bottom of the main block. And then lastly, we create the nubs for the bottom. So that's kind of what our code does here. Create the main block, we create all of our nubs on the top, we remove the bottom, then we create our nubs for the bottom. So this is looking really good. What I noticed though is I'm using a lot of the same numbers, right? Like up in here, I have the height here. These are all just defined as numbers instead of being defined as variables, which if you're coding, you really want to define everything as a variable because it makes it a lot easier to change. Like if I wanted to change the size of that block, I'd have to go in here and manually change all the different sizes, all these different numbers, and all the different ranges, and that becomes really tedious. And so I want to assign these to variables so I can manipulate it a little bit easier, right? So let me go ahead and do that real quick. I'll say the width is equal to 4. I'm starting off with this subdivision in the x. So the same number as this is what I'm assigning to here. The depth, I'll say, is equal to 2. That's the subdivisions in the z. My size y is equal to 1. Size x equal to 3. And size z is equal to 1.5, right? These are just the values from here. Height 1, 3, 1.5. And now instead of assigning numbers to this block, I can just assign these values that I've already defined up here. So for my subdivision of the x, I can say that's equal to the width, right? And the z, I can say that's equal to the depth. For my height, that's equal to size y. width size Z, or I guess it's size X, and depth would be size Z. Right, it's the same thing as having these numbers here. It's just now I can change these numbers up here and make it a little bit easier to manipulate. So if I run this whole thing, it's going to create the exact same block we had before, right? Everything still works. Everything looks good. I've just transitioned these numbers from being inside of here to up here. And that makes it easier because now what I can do, oh, let me get rid of that, delete this object. Now what I can do is say, okay, for my for loop here, instead of saying that as 4, I can make that just the width, because that's the same value as I have up here. And this could just be equal to the depth. I want this to change whenever this changes, right? Down here in my other for loop, I can say, okay, I want this to be equal to the width minus 1, right? That's what we were doing before. Instead of having a 4, we wanted a 3. The depth down here is also minus 1. Instead of having a 2, we wanted to have a 1. That's what our error was before. So now if I highlight all this, run it, we get that same block that we had before. Everything still works. We've just transitioned from using numbers in our code to variables in our code. And that makes it run a little bit more efficient. And now if I go up here and I change any of these variables, it will also change the block, right? And that's going to be useful here in a bit. So this is looking really good. I can kind of take this to the next level now, and I can combine all this code into what is called a function. Okay, so I can say, okay, I'm going to take all this, I'm going to define my function as create block. And I'm going to highlight everything and just move it over a little bit. So now I have this definition, my function, as create block. At the very end, when I'm done executing this function, I want to return my block, right? This is the variable that I have created that is our Lego piece, our Lego block. And then as I'm done at the very end, I'm returning that block. So now what a function does is the exact same thing that was happening before. Everything inside of our function is going to get executed whenever we call this function. But if I highlight it right now, I hit Control Enter, you can see it executed it, but nothing happened, right? Nothing happened in our code. And that's because we haven't called it. So if I go down here at the very bottom and I say, okay, I want to call this create block function, now it's going to say, okay, it knows what's in the create block function, it calls it and executes all the code inside of that function, right? So let me highlight everything, Control Enter, there we go. So it's executed this code, but it only executes whenever you've actually called it. And that turns out to be very beneficial, and we'll see why right now. Let me delete this. Let me go in here and show you another piece of Maya that is really, really quite awesome. And that is that you really have access to every single thing that is inside of Maya. There's some kind of function. You have access to all the functions that make up all the different windows and all the different materials and all of the different polygons that we've seen as we were creating these blocks. And it's really cool. So what I can do is I can just come in here and I can say, okay, I want to make a new window. And that is going to be, again, my Maya command is window. And I'm going to make the title of this window Lego Builder. And I want it to have a menu bar. So menu bar is equal to true. And I'm just going to assign the width. Right? And then I'm going to say, okay, I want to commands.show this window. I've called it window. So if I highlight this, only this, and I hit Control Enter, we get an error, invalid syntax. So that's because I forgot to put the equal sign here. I just said title. Title equals Lego Builder. Let's try this again. Control Enter. There we go. So we see a little window popped up, and it's nothing in here right now. I can actually make it a little bit larger so we can see, but it's blank. But we have a window and it has a title. It says Lego Builder, and we have these little options here that we can, exit out. And so now we can start adding some objects inside of here and just kind of create our plugin from the ground up. So I'm going to add a couple of sliders. I'm going to say, okay, I want the commands dot, I want this to be a integer slider group, and I want to say, okay, this name is going to be block width, and the label, I want it to be equal to block width. This is going to be a field, which means you can enter in a value. So field equals true. The minimum of this field I want to be 1. The maximum I want to be 10. And the starting value I want to be 4. So let's run this and see what we get. Here we have this Lego block width. It's started out as 4. We can change this slider and it manipulates the value there. So that's pretty freaking cool. We just created a slider inside of Maya using some Python code. And I can just copy this line of code, paste it. Oh, Control Z. Copy, enter, paste. Call this the block depth. Change the label to block depth. Starting value at 2. Now if I run this, we have 2 sliders. Block width, starting at 4, and block depth, starting at 2. That's pretty cool. Of course, nothing happens right now because we haven't assigned it to anything. What we want to do is have a little button down here that we hit. Whenever we hit create, it makes the block that's assigned to that width and that depth. So let's make that button. Let's say, okay, I want to commands.button. And I want the button, the label, to be equal to, let's see here. How about create block? I don't know. It can be whatever you want. Let's run this. And we get an error, invalid syntax. So I think I put that. There we go. We get another error. Let's see here. Contain must have a layout. Okay, so we have to make a layout. And that is easy enough to do. Just say commands at the very top here. Dot column layout. And this can be named anything you want. I'll just call it block. So Maya requires that you have a layout whenever you're making these windows. So we're just making a layout here. And now when I run this, it should, make everything properly. So here we go. We have our sliders that can be manipulated. And we have our button here, create block. Now, whenever we click it, nothing happens because we haven't assigned it to anything. But what we want is whenever we click it, we want it to call our function that we've created that is the block function, right? So now, if I go in here and say, okay, whenever you click this, I want it to call the generate block function that we have down here that we've made. And that's the whole point of making something into a function, is that you can call it whenever you want, instead of it just executing kind of on its own. You want it to be executed only when it's called, right? So now it will only execute whenever we click that button. Let me go ahead and delete this, highlight everything, Control Enter to run it, and let's see what happens. So we have our create block button here. I assign this to 4 and 2, hit create block, and boom. We now have created our block. It's a 4x2. Let me move this out of the way. If I adjust these sliders to 7 and 2, you'll notice nothing changes, right? It still creates a 4x2 block. Why is that? Well, that's because we had that assigned here, hard-coded. Remember, it's our width is 4 and our depth is 2. So every time it calls this create block function, it's just going to make a 4x2 cube, and that's it. Well, we don't want that. Remember, we want it to have the values of the slider and use that as its determination of how to make the block width and depth. So what we need to do is we need to come in here and we say, okay, instead of using just a number 4 for our width, let's assign to whatever the slider value is, right? So we can do that easily by saying, okay, commands dot our slider group, and the name of our slider group up here is block width, right? So I can copy that, paste it. So now we're going to say, okay, I want to set Q equal to true and V equal to true. So we're getting the value from this particular slider, right? And we want to do the same thing with our depth. So I'm going to copy this, get rid of that 2 value. Instead of the block width, I want the block depth to be assigned to this depth value. So now what we get is we have our width assigned to our width, which is then used throughout our entire code as our width and depth, right? Throughout here as our for range, as we're creating our nubs, and as we're creating our nubs on the bottom. And it's also being used to adjust the size of our block, our starting block, right? But it's not being used to adjust like the height, the width. That's only here on this size. We've defined that as 1, 3, and 1.5. Well, we want to change this then to somehow incorporate this width and depth slider. And we can do that by, let's just say width is multiplied by this, but instead of 3, let's do 0.8. And again, I've kind of messed around with these values so I have an idea of what is going to work good. Our depth can also be our size z, and multiply that by 0.8. And our height, instead of 1, let's make it 0.96. So now here's what we have. Our size x, y, and z are all assigned and are getting some kind of value from our sliders, because these sliders here are getting a value from the slider up top. So that's great. As we go through our for loops, we are also getting a value of our width through this variable and our depth through that variable, but nothing is actually adjusting the movement here. You see, we're only moving based upon our width and depth. We want to move based upon the size of the cube as well as we're going through and moving these nubs. So let's go ahead and assign our size x and y to our move x and y and z and see what happens when we do that. So I'm going to go ahead and say, okay, for our y here, we want to say size y, and we want to divide that by 2.0. And I'm doing this because I have found that these numbers are the best ones to use as we're creating this. And you can go through and you can kind of change these numbers, manipulate it, see what happens when you do, and you'll notice that things might just be a little bit off, like the nubs might be in the right spot, or the block might be a little bit too big, or whatever. So these are the values I've found that have worked pretty good. For our x-axis, we want to assign our size x, and we want to divide that by 2 as well. And we can kind of just leave this maybe 0.5 instead of 0.55 and make it 0.8. Similarly, we want our size z to be down here, divided by 2.0. We'll do 0.5 instead of 0.55. And that looks pretty good. That assigns our y, our x, and our z to our move y, x, and z. So now it's going to be resized based on the initial size up here. That's looking great. One thing that I noticed, though, is that we don't have it assigned to our bottom remove or our nub remove. So we want to make sure we're assigning that to there too. And let me show you what happens if we don't. Like if we just kind of leave this the way it is, and I run this, we'll see what happens. So I'll hit Control Enter. We pull this up. I'll say block 4x2, hit create. Everything looks like it's working great, right? Looks good. But now if I go ahead and adjust this, I'm going to say, okay, I want the width to be 6 and our depth to be 3, right? Hit create block. What happens at the top, it looks somewhat good, right? Because we've already adjusted, we've added these size y's and x's to our top nub section. But at the bottom, you see here, it's all jacked up. It's not correct. And that's because it's still sizing this based on if it was a 4x2 block. Well, it's not a 4x2 anymore because we've adjusted these sliders. So we need to add that adjustment inside of our remove bottom section here and our create nubs for the bottom. All right, it needs to be moved properly. So you can see it's created the proper amount, and that's based on this width and depth right here, but it hasn't moved it properly. So we need to assign, kind of like what we did up here with our size y and size x, assign those down here so it gets moved to the proper location. So I can do that easy enough. I need to go back up here to our remove bottom and make the height the same as the size y. Make the width the same as the size x, except I want to be a little bit smaller than size x. I'm going to multiply all that by 2. Depth size z, a little bit smaller than size z, and multiply it by 2. Now, this fixes our problem with the position of our nubs on the bottom. So if I delete this. If I exit out of here, rerun everything, highlight all of it, Control Enter, make a little bit larger, 5 by 2. You can see we have the proper amount of nubs, but the proper, I guess this is the remove bottom is what we've done here. So now the bottom is being removed perfectly. So if I make this a larger 6 by 3, let me delete this one. This bottom gets sized properly. Now it's removing the proper amount. You see, but the nubs here on the bottom are not positioned quite right. So that's what we'll fix right now. Let's go ahead and go in here, and it's just going to be similarly to what we did up here with our size Y, size X, and size Z. We're going to add this to our bottom. So we'll start out. Let's go ahead and do size X. So it's negative. Actually, it's negative size X divided by 2. And we'll leave the rest of it the same. And we'll just say negative size Z divided by 2. And the rest of it can be left the same. So now that we've assigned these variables to our nubs on the bottom, hopefully, if we highlight everything and run this, what we're getting here is the proper amount of nubs at the bottom and the proper spacing as well. So there we have it. Now everything's in the correct position. Everything on the top looks really good. If I move this over, I can create any size of block now I want. And it will automatically create the proper nubs on the top in the proper position. It'll create the proper nubs on the bottom in the proper position. And it will remove the bottom now at the proper size. So everything is working perfectly. We just created a Lego block generator plugin using Python inside of Maya, and now we can use this for any future projects we want. And it's a pretty cool accomplishment, pretty cool achievement. And let me show you how you can save this. Say like you don't want to enter in this code every single time that you want to use this. So what I can do is I can say, okay, let me go up here to my settings. This is the shelf settings. Go to shelf editor, and I'm going to go down here at the very bottom. I'm going to add a new one. Okay, I'm going to call this custom scripts. Hit enter. So now I have a new shelf up here. You see next to xgen custom scripts. I can go here into my script editor. I can say file, save script to shelf. I'm going to call this Lego maker. Hit OK. And now I'm going to get rid of my script editor, delete everything in my scene, and now you can see we have a little icon up here, a little button up here that we can click on. And every time we click on this, it pulls up our Lego maker. And now we can just go about generating our blocks and generating whatever we want. And if I want to get rid of it, I'll hit exit, and I can just leave it up here. And anytime I want to bring it back up, I can bring it back up. And now we have our Lego generator. So we just created a plugin inside of Maya using Python, and then we can use this for any of our projects anytime we want. And it's pretty cool. I really like this tutorial. So see if you guys like it, leave a like down below. That's all I have for you today. Maybe I might keep expanding on this, make a little bit more options in here. You know, maybe you can have an ability to texture them or color them, or more options for different types of blocks. This is obviously a more simple Lego blocks. You can only do so much with this. So if you guys want that, leave a comment below. Let me know. And otherwise, I will see you guys on the next tutorial. Thanks for watching.